Hi students, welcome to week 5. Tonight's lecture I'm going to talk a little bit about some of the architecture behind a lot of these EHR systems, modern and old architectures, which for the most part involves the user interface and databases involved. The user interface or the clients generally fall into one of three categories, although that's becoming more and more diverse all the time. The original interfaces were all written in something called a character user interface, although I don't think they were called character user interfaces then, since there was only one type. These are the old DOS-like screens. In some cases they were called CRT for cathode ray tube. They generally provided a 24 line down by 80 character across text screen. In some cases it wasn't even that much. It was 40 characters across by 24 down. They were replaced in the mid to late 80s, or started to be replaced in the mid to late 80s, by the GUI, the graphical user interface, dominated by Windows. These are a lot of times referred to as the thick or fat client, and an awful lot of processing could be done at this level, and therefore really was. That was the area where developers did most of the business logic. The rules were embedded in the logic of these GUI or fat clients that sat on the desktop and had to be installed on the desktop. They had been replaced slowly over time by something called the thin client, usually web-based. These are your web user interfaces, although a lot of the things like your smartphone applications fall into this category as well. And also the lecture notes mention Citrix becoming widely used. This is very widely used at Sutter. This is an exciting topic because these are things that we're going through right now. My team personally is involved in developing the thin client or web-based applications, but we work closely and we're involved very closely in the deployment. An awful lot of applications that exist out there are either GUI or character user interface, but even the character user interface ones generally require certain software to be on the desktop, and that's expensive. Maintenance of software, particularly at the GUI level, is very expensive on the desktop, and it puts you at some risk because you are saving rules on the desktop. And if that desktop, which could be a laptop, gets stolen, you have some exposure, serious exposure there. So in general, the fat client, the GUI, the desktop is not liked by anyone, least of all the hospital. Um, so we're getting rid of them. Citrix is a really nice environment, which the team mentions, and we're using it and we're testing it out. Basically, what Citrix does is it creates a virtual Windows environment that is running off of a server, a Windows server somewhere, and any computer can attach to this server and run these applications. And it's like if anyone's ever used GoToPC, it's basically that's an example of Citrix. Um, or remote desktop is another example. Essentially, if you're using a Citrix application, your keyboard and your mouse and your monitor on your computer are essentially running an application on another computer remotely somewhere. That's Citrix. The application is not running on your computer. It's running on another computer. It looks like it's running on your computer, but it's running on another computer somewhere on a server. That's Citrix. It's great technology. This allows any type of operating system, whether it be Linux or Mac or Windows, to run an application that was specifically written for Windows. And that's because it is running on Windows. It's running on a virtual Windows environment on a server somewhere in a secure data center. It's great technology, Citrix. We love it. And we are deploying it. We are replacing all real desktops with Citrix. It's also going to save a lot of money. First of all, the virtual terminals that replace the real desktops use a lot less energy because they don't have hard drives. They don't have any of the expensive components that drain electricity, so they're a lot greener. I mean, this is green technology too. And second of all, your exposure should one of these units be stolen is zero, because there's nothing stored locally. Everything is stored on the server. So these things are great, great technologies. And now also it allows people, typically in the medical world, doctors love Macs. And I don't blame them. I love Macs too. I used to work for Apple. I think it's a great computer. I own a Mac. They're great computers. They can run these Windows-based applications on their Macs. And they're not running them on their Mac. They're running the Citrix client, which attaches to a server that's running Windows in a virtual mode. So it is really great technology, Citrix, and we're embracing it completely. It's great technology. One of the things that they also talk about is databases, mostly relational versus hierarchical. Relational is really the dominant model that's used today. It is taking over from hierarchical, and another model that existed previously was something called network. Hierarchical existed before relational. The relational model basically is the new model. I have a link actually to a course on my website that teaches the relational model using MySQL, although the concepts are all the same. So if you want to look at that, look at that. The relational model was created by IBM in the early 70s, but it was implemented by Oracle. Everyone's heard of Larry Ellison. He implemented the first relational database in the early 80s, and then IBM figured out that although they invented it, they didn't think the model workable. Well, Larry Ellison proved them wrong, so they implemented the second relational database called DB2. Microsoft SQL Server eventually bought the source code from a company called Sybase and implemented their own relational database. The open source world being what it is, of course, is an open source relational database called MySQL. And that's what this course teaches is relational model using MySQL, although it doesn't really matter. SQL, or Structured Query Language, as that's what the initials are for, is a generic language used by all relational models. And even some of the non-relational models like hierarchical allow SQL to be used to interface with their databases because it's such a flexible language. Some of the hierarchical languages that are still around are the ones that are used by Epic, of all things. Epic, being written on a fairly modern client .NET platform, still uses a hierarchical database called Cache. They claim that they are the fastest database around. I don't know if that's true. It's based on MUMPS, which is a really old database. The slides point out that MUMPS predated C language, which is the granddaddy to Java and a lot of other modern languages. It's the direct daddy of C++. And bragging that you were around before C, I don't think really is impressive in the computer world where we want everything to be modern. So hierarchical, they're probably the last hierarchical database out there. But because they're in healthcare and they're widely used, they're still around. Cache does allow a SQL interface so that you can use it more or less like a relational database, but it's not truly relational. Almost the entire world uses relational. Epic is really strange. It uses a very modern client written in .NET, but a really old database based on MUMPS. But it's kind of the way these things go sometimes. But the relational database is really the modern database. And although, because products like Epic are out there and they're the number one product, they use a non-relational database, the relational model is not 100% in healthcare. It's virtually 100% in every other industry, but healthcare. And in many healthcare areas, it is. Just to point out a couple of other products, Eclipse Sunrise Clinical Manager. Eclipse has many products. The one we use is actually character-based and runs on a Unix platform. It is not .NET or SQL Server. Actually, we tried to implement Eclipse's Sunrise Clinical Manager over 10 years ago, and we failed. Of course, that was 10 years ago. I'm sure it's improved a lot since then. But it is written using SQL Server, Microsoft SQL Server, which is their relational database, and Microsoft.NET, which is their modern programming language for writing both thick clients and thin clients. .NET can be used to write both Windows-based thick clients and web-based thin clients. eClinicalWorks is a open source product written in the language Java and MySQL and Tomcat, which is a fairly typical combination for open source development. We actually use Java, and we use a commercial implementation of Tomcat called JBoss for a lot of the thin web applications we write. So eClinicalWorks also, by the way, is probably a thin client. I don't think these slides specifically say it's thin client, but usually this sort of environment means thin client. Tomcat is a web application server for Java, so almost certainly this is thin client, even though the slides don't say it. Or at least I didn't hear them say that. That was about it for week 5. Very interesting week. We went over architecture. I think it's very important to understand these concepts. I work with these architectures all the time, so it was quite interesting material. Go over it again if you haven't gotten over it. For the activity for this week, I'm going to post this. I'd like you to, the slides mention the online buyer's guided hymns. I'm going to upload this as well. I would like you to go ahead and do this stuff. Go to the website for the online stuff, workstations and desktops, and go ahead and follow these steps. I'm going to upload this document, and I did not give you an activity last week. I'm not giving it every week, probably like every other week, so you don't get overwhelmed. But this is a good activity, so go ahead and do that. Okay, that's about it. And make sure, if you're not keeping up on the material, that you're at least sending me an email, because Mission College wants to know who's still in this course and who isn't. And if I don't see any activity online from you, I'm going to have to report to Mission that you're not active, which means they might drop you. So make sure you're being in contact with me if you're falling behind on the work. Okay? Thank you.